Hi and welcome back to the lab. And today I have good news. So we are going further with our Heathkit restoration. So which is our HW12. So that is the 80-meter band monobender. And of course with its power supply, the HP23A. Which we have already started, and we found a lot of bad capacitors which we need of course to replace, and it took a time to decide how we're going to do it, because the original capacitors which are in here, you can still get them, but well, they are really expensive. So we were searching for another idea how we could do it, and now we know how we wanted to do it. So let's go to the bench and let's show and see how we can go ahead. Okay, and that is here part 1, which is video 244, and I put a link down below here in the video part 2. Okay, and here is our power supply, and that are the capacitors which we need to swap out, because they are electrically leaky, and yeah, therefore we found some new capacitors which are this here. So I have one out of the back already. So you see 450 volt and 150 microfarad. So we have here also 125, I believe, microfarad, and 450 volt. So yeah, it's a little bit better now with 150, and you already see, of course, the difference here in size. So we leave these capacitors in, as that is how this power supply looks naturally, and therefore of course we go and put new capacitors down here, underneath. And since we have fairly enough space, so we can sort it here somehow, that we really have the new capacitors here underneath. And if you look at this unit, you think, oh nice, it is all originally. But then one big question was, how can we really connect the new capacitor to the old stuff here, because we need a kind of post where we can solder it to. And therefore normally we have, so let's see what we have already done here with the second capacitor. So you see that normally we have here our contact, which is this one here, where we had our connections connected to, right? And well, so I was simply trying to pull it out. So I grabbed it here, and I really was pulling it out until it came off. And that is the contact which we do not need any longer. And well, still we had the question how we can arrange it. And you see I have here this additional post which we simply screwed down here into the old material, because inside there we have still our old capacitor material, and there's a lot of tar in this old capacitors. So I have simply taken this kind here of post, which we see already down here, and well, we have simply taken here a screw, something like this here. Let's see that you can all see what we do, and you see then I'm able to screw it here simply in the old material, right? And that leads me then to the new situation where we have here of course a new post where we can our new capacitor finally solder to, and of course we have additional to that some other parts to connect to this post as well. And for instance, we have here this two diodes which needs to get back here into the circuit. And well, now the leads here a little bit too short, as you can see, but that is no problem because we can replace this old diodes with more modern 1N4007, which is a 1 kilovolt type and 1 amp, I believe, which will nicely replace this old. I mean, it is still working fine, but you know, as you can see, the leads are now a little bit too short, and therefore we replace them with newer diodes. And then of course we have to replace here this capacitors, and you see, for instance, this old 40, is it a 40? Yeah, 40 microfarad electrolytic 450 volt DC, and I thought it is nice to replace it here with a 56 microfarad type. And since this is much smaller than we had in the past, we will be certainly be able to put it up here so that it really does not take too much space, and that then makes it much easier to put here our new 150 microfarad capacitors in. And so I think that is a good idea to replace it with it is a little bit on a budget, but well, we have to look around, and in Europe, you know, it is you can buy them, but well, it is really too expensive, and this, we believe, is really a good replacement. And so yeah, let's start, and let's go ahead taking this old capacitors out. We first replace them, and then we go ahead. So that means our first step will be quite easy, because we simply snap them out, and then we think about how we put our new capacitors in. First, of course, the values we have taken out, and I can clean it here a little bit, and then let's see. Okay, so we are already making progress. So you see I've here put the first new one in, which is replacing this big one, and I'm really trying to use as little as possible space to be really able to get all the capacitors we need now here underneath. And you see I'm already preparing this one, which is one of those who is replacing the old one, this, which is only 150 volt DC 20 microfarad. I'm replacing it with 47, so that should be fine. And you see I'm trying to figure out what is best, because of course we need to put here a second one, and yeah, so let's try to go ahead and let's see how it is getting to the right way. And again, as you can see, I try to use as little space as possible for this both capacitors here, to have enough space for now to replace here our bigger capacitors underneath. So let's go ahead. Now, by the way, I have of course tested all resistors here, and all resistors you see here are well in spec. So you see we have here a silver marking, which is indicating for 10% tolerance, and every single resistor in here is within its tolerance, so that is fine. Well, and again, let's discuss here our new posts, which we need to connect all the parts and wires we need. And you see here is what I've already done, and I already told you that we pulled out here the old post, because we cannot only substitute the old capacitor with a new one, simply because we have a leakage, an electrical leakage, and therefore we really need to isolate you know, the old capacitor from what we are going to build new. So therefore we have taken this new posts here, as you can see, and I simply take here a normal screw, which we will then put here right into the middle. And well, we really need to be clear that we screw here into our old capacitor, and that means that of course there is then a kind of connection to the old material, and that means that here our screw is directly here in our old capacitor, which means that we need to isolate here our screw head from our new connections as well, because we really have to avoid that whatever we do now gets in contact with the center here of our screw, right? To really avoid that we involve in any way our old capacitor. Other than that, it is here really straightforward. You simply, as I already told you, you simply screw it in like so, right? And now we put it down, and then we have our new post as we need it. And we already discussed that we need to replace here our old diodes, simply because we need to cover the new distance. And what I have here, so that is 4007 1 and 4007, which is 1 kilovolt type. So and you see this is easily able to cover the distance for what we need, and therefore that is fine, so no problem. And you see that we have here our first new capacitor in, using our new posts, and well, the new diodes are in as well, and our coil here, our choke coil, is already connected back. So we are making progress. Okay, so you see our second capacitor is in, and well, we have now to continue here, and in this area it is now getting very tight in order to be able to work properly. And the first, of course, what we need to do here is to pull here the old posts and put here our new solution in. So let's see how we can get that done. So I'm not entirely sure if I can really demonstrate it to you, but basically it is that you need to grab the old post, and then you need to wiggle it back and forth and back and forth, and definitely it takes a while, and of course it takes some force and some patience to get it here finally out, but I think it is clear that we really should get it out, since we have really to avoid to get any contact to our old capacitors, which are now only a shelf queen or what. Yeah, and after really wiggling here a while back and forth, we really have it out, as you can see, and now we really have here a better situation to replace here our new posts, and then let's go ahead. Right, so our new post is installed, and we have to replace here this red wire, which needs to go here to the post as well. Simply because it is a little bit too short, and you see it does not really look very nice. So we go and replace this wire here, and then I believe we will be able to finally wire your third capacitor up in the way we need it. Okay, so as you can see, we have all capacitors in, and we are still our original optic. So that means now we need to take care here on our fuse, of course, and our switch. So that needs to go back now next, and yeah, let's see how close we are getting to our final point where this nice power supply should work again. Okay, so now we have here quite a bit of chaos here with our switch, and I believe that makes no sense to try to take it as it is. I believe we should simply cut it all off here, and let's try to do it new, because yeah, really that is really needless here. So okay, let's try what it is, and let's do it new. Okay, and as you can see, we are almost ready. So you see here our switch is now rewired. We left, by the way, the 300 volt switching option not connected, since we only need 250 volt. So that is what we see here, right? So we do not have connected the 300, but we have connected the 250. So that is that not by you know, something goes wrong and you switch it to 300 volt, which might not be so good. So we only put it on 250, and that is all what we need for our 80 meter monobender for our what is it, HW 12, yeah, it is the HW12, right? I always have to look to the front panel of the radio. Anyways, yeah, so the only what we still need to do is here, so that is not ready yet. We have here still our loop, which we of course need to take out. But other than that, you see now it is a little bit more crowded, simply because we have here our new capacitors, and that all needed to go here underneath. And I think, well, it really makes a good impression. So we were able to fit it in quite nicely. You see our new posts here, because we are using in a way our old capacitors. So the new posts are functional, they are working, and of course we had to replace some of the original diodes. Simply, you remember, because the leads were too short, so therefore we had here some. Can you see it? I don't know. Yeah, but you know what we have done here. So we have our 1N4007 here in the project, and well, so we are really ready for testing. So normally everything should be fine, and let's hope that, as I said, our circuit is now working, because that really would mean we are ready with part 2 of our restoration, and the next then would be our radio itself. Okay, moment of truth. So of course we have already connected our radio to our transformer, and well, we have our regulation transformer set to 0 volt. Now we switch here to 250 volt DC. That is the needed voltage we need for our radio. And now let's go over to my power analyzer, and then let's crank up our transformer. So, okay, everything is prepared. I tried that you were able to see here our transformer as well when I start to crank the transformer up. And yeah, all is switched in. And you may remember when we did our first testing with the old capacitors, we had significant high current draw, and well, let's see what will happening now. So you see here the voltage which we are cranking up, and you will see here the wattage and here the amps which will be drawn by our unit. I hope that I did not make any errors during rewiring, so that would directly lead to a malfunction or maybe a short. Hope we don't see that. So let's go up, and of course the system here is connected or wired for 240 volt. So we have 230 volt here. So that should be basically fine. So you see, up to now it looks quite okay. So of course we have some current flow, because there are a lot of resistors which we have here in the circuit, and that means of course we have current, but it should not be too high. So therefore let's slowly go up to 220 first. Okay, so we are at 220. So we have 17 watt, we have 190 milliamps, which is, from my point of view, fine. Now let me go up to 230, let it run here a little while, because we have new capacitors in. So we see we do not have a short, because we would see it. and we have no magic smoke so far, which is good. And okay, so let's go up to the rated voltage, which is 240. Okay, so we are at 240 and we have 19 watt, so that seems to be nice. So now let's go over to our product, because we need to check the different voltages. Okay, and what we see, we have minus 131 volt, and we are here at our minus 130 volt line, and we are here at ground. So we are testing for DC, and minus 130, that already looks quite good. So now let's go over to LV, which is our lower voltage, means that should read 250 volt. Let's see what we have. So very nice. So we have 264. So of course we always have a delta, which is a kind of normal. Here in this case it is a little bit higher. And now let's see what we have on our high voltage, which is of course for on our transmitter circuit. So, and here we have 806. Very nice. So that all looks really, really good. Then we have an adjustable bias, and that should be, not sure, here, down here we have our adjustable bias voltage, which is, as you can see, at minus 84, and I'm now interested if we are able to adjust it. And yeah, if you, as you can see, that is working fine. So it is rated somewhat around minus 40 up to 80, and that really looks pretty nice. So that makes it easy to adjust our bias on the radio. So you may remember that our bias control was not really soldered to the post when we did our first inspection. Now we can be sure that it is working perfect. Okay, and of course we have now to test our filament voltage, which is of course 6.3 volt. So therefore we have to switch it to AC, and well, we have to go to filament common, which is down here, and here we should be able to read 6.4 volt, which is pretty nice. And this here should be 12 point something, 12.9. So we see in the schematic it should be 12.6, which is fine as well. So our filament AC voltage is given as well. So what can I say? All voltages are really present. So we have everything we need to be able to operate our radio. So that means our work here on our power supply was successful, obviously. And the nice thing here is that we have here our original look. So that is now still there. Also we have modern electronics inside, and that is really nice. What I just want to know as well is if we have wired up our switch in the right way. Let me see what we can do. Maybe we go back here to our negative voltage, and let's switch it off here, and you see our negative voltage is dropping, which is what we of course expect, and we see the discharging of our capacitors. Now let's switch it here to 300 volt DC, and you see there is nothing really. So what we see seems to be still discharging. You see, now we switch it in. Now we see the discharging process, the same we would see here on our positive low voltage, which is now dropping, and that goes a little bit slower because the capacitors are bigger, and that's the reason why with inner resistor of our meter here of 10 mega ohm, it takes its time. But what we see, it is going down. So that was the reason why I was choosing here the bias voltage, the fixed bias, and you see it is almost zero. And now once again switching to positive 300, and you see it is dropping. The capacitor which is there is dropping to also zero, so that means our 300 volt switching is ineffective, which is what we wanted. And when I go now, of course, back here to low voltage, we have it switched in, and that is what we can see here very nicely. So that means that obviously now all functions are really given, and our power supply is really working like new. Okay, so the last what we did here is we wired up here our mains cable as we need it, and we put in here a new rubber for our electrical strain relief. And of course here our electrical strain relief is very old school, but it is effective. If you see, we really can pull it here hard, and it is holding here our mains cable, and you see here, so that is a new rubber. So everything is done. Additional to that, I did some additional isolation here on our new posts, and I tacked down here our capacitors with hot glue, so that they are a little bit fixed here. And yeah, so that is all what we needed to do. So the last thing is here our loop, and I need that until I start with the radio itself, and then that of course gets off as well. And well, so that's it. That is what we needed to do to get here our old power supply back working. Okay, and that means we are ready with the restoration here of our power supply. Everything is fine. Next step will then starting with our radio, so the restoration for our radio. That will then part 3 or episode 3, which this was episode 2. So stay tuned for our radio restoration in the future. Thanks for watching.